I'd like to talk to you now about how do we find out the present value. So if we know how much you need in the future, how much do you need to invest right now to get that? So in this particular word problem that we have, it says that Leslie is saving up to buy a car in 3 years. Okay, if she's saving up to buy a car, she doesn't have the money right now, but she's going to have an idea of how much she needs. Okay, she knows that a decent used car costs about $7,000. How much would she have to invest now, right now, okay, at 4.5% per year, compounded monthly in order to have enough to buy a car? So let's unpack this. Again, we know that this is going to be a compound interest problem, and we know that because it says that it's compounded monthly. All right, well, if it's compounded monthly, we know that monthly means 12 times per year. We know that the rate is 4.5% per year, so we can actually convert that into a decimal, which is 0.045. Okay, we know that it's going to be in there for 3 years. That's a helpful bit of information as well. And we know that she needs to have about $7,000. Okay, now that means she doesn't have $7,000 right now. Okay, the question says how much would she have to invest now? So she needs $7,000 in the future, and that means that this 7,000 is actually our A value. It's a terrible A. Let me try that again. So our A value is $7,000. So what we don't actually have is our P value. So let's go through and identify our A, P, I, N values. Okay. So we know that the future amount of money that she needs to have is $7,000, so we can fill that in. We know that the principal or the present amount of money that she needs to invest, that's our unknown. It says how much would she have to invest now? So this P value is actually our unknown. We don't know that. Our I value, we know that I is equal to R divided by the number of compounding periods per year. So our I value is actually 0.045. 0.045 divided by 12 because there's 12 compounding periods in a year. So our I value, if I calculate this correctly, 0.045 divided by 12, that's going to give me approximately 0.00375. Okay, so for each compounding period, that's the interest that's paid on it. The N value is the total number of compounding periods over the life of the investment. We know that there are 12 compounding periods per year, and we also know that the investment is going to be in there for 3 years. So 12 times per year times 3 years gives us a total of 36 compounding periods. So in this instance, because we're trying to find the present value, we need to use the present value formula. So our present value formula is actually P is equal to A times 1 plus I to the exponent negative n. Okay, it's very important that we use the exponent negative n for this. So now what we're going to do is we're going to substitute in our values for A, P, I, and N. So P, that's what we're looking for, so we're just going to keep that as the variable P. The future amount of money that we need, that's our $7,000, so I'm going to plug that in to the equation. And 1 plus I, we figured out that our I value was 0.00375. 0.00375. And our N value is negative N. So negative, and then our N value here is 36. So negative 36. If I clean that up ever so slightly, I can do that addition piece. That's in the brackets. So that means that inside my brackets it's 1.003 375. And again, to the exponent, negative 36. So if I want to solve this, what I do is in my calculator, I'm going to put 1.00375 to the exponent negative 36, all times 7,000. Okay, and that means that my final answer here is going to be $6,100 or $6,117 and approximately 56 cents. Okay, so my present value, the amount of money that I need to invest right now in order to get a return of $7,000 is $6,117.56. Okay, so again, when you're looking at word problems around present value and future value, try and figure out very quickly if the person has the money right now, then that's the present value. If they need money in the future, that's the future value. Okay, so in this case, she needed $7,000 in the future, so we already knew that. So that means we were trying to figure out how much she'd have to invest right now.